In the previous video, we saw that fossil fuels have some good properties, but the amount of carbon dioxide that they emit is so high. So the conclusion was that we need to replace these fuels with another kind of fuels that has more or less the same good properties as fossil fuels, but with a lower level of emissions. One of the fuels that is interesting is hydrogen. Hydrogen, we will see in this video in which what is this technology and which is the level of development and the potential that it has, this technology. Well, let's start seeing what is the meaning of using hydrogen. Well, we saw in the previous video that when we burn fossil fuels, these molecules were composed by carbon and hydrogen, and okay, the hydrogen generates water and it's no problem, but the carbon mixes with oxygen, releasing carbon dioxide, and this was a very bad property. So the thing that we have to replace is, or we have to remove is this molecule. Well, if we use hydrogen, we are removing, in fact, we are removing the carbon from the equation, and this means that we only keep the hydrogen in the equation. When hydrogen combines with oxygen, it generates only water, and that is the interesting part of this fuel. Well, if we compare, it's more or less the same. So the atoms that are involved in these two equations, in these two reactions, are more or less the same. The only one that is removed in this case, in the case of the hydrogen, is the carbon atom. So it's the perfect, in this from this point of view, is the perfect fuel, because it only releases water to the atmosphere. Analyzing the heat of combustion, we see that hydrogen is also a very interesting molecule, because the amount of energy that it releases is very high also. It's so high. And a second good property is that the mass of hydrogen is so low. So the hydrogen molecule it has a very light weight. And this means that if we calculate the heat of combustion in terms of megajoules per kilogram, we obtain a very high value. And this is also a so interesting property. That it's higher than the heat of combustion of gasoline. This means that this molecule is very interesting to be used in vehicles that needs a very high power, like for example buses, trucks, so vehicles that has very large masses, and because of this they need a lot of power. Let's gonna see now which are the way to obtain hydrogen. Because hydrogen cannot be obtained from nature, so we can not obtain it on a mine, we cannot obtain it from the atmosphere, there's no way to obtain it from the nature, so we need to generate it in some process. And depending on the process that we use to generate it, we name this technology with different names. The first way to obtain it is using methane. Methane is a molecule that has 4 atoms of hydrogen. So if we remove the carbon from this molecule, we leave only hydrogen. And this is the way to obtain. This is one of the ways to obtain hydrogen. But the problem is what we do with the remaining carbon. If we emit it to the atmosphere as it was simply a combustion, we name this technology gray hydrogen, because it's not interesting, because at the end we are also releasing carbon dioxide into the atmosphere. But we can do a better thing with that carbon, that is to capture it. We can capture it in the soil, we can capture it, for example, liquefying and putting inside the mines. So there are several ways to capture the carbon, and if we do this, the technology is named blue carbon. But we are also generating some kind of carbon that it's not released into the atmosphere, but it would be more interesting not having the carbon atom involved in the process. And this is what we do in the green hydrogen. With green hydrogen, we produce hydrogen just from water, and we do it with a simple process that it's called electrolysis. Electrolysis is it's just a process where we put a difference of voltage inside the water, and with this difference of voltage, it appears an electric field that makes that some of the water molecules splits in two ions, one hydrogen ion that is positive and one negative ion that is oxygen, that they go to the different poles of our difference of voltage. And in one side that we see here, we can collect all the hydrogen atoms that they emerge from this splitting of the water, and they combine in form of hydrogen molecules that then we can collect and put inside some bottles. This process requires a lot of energy, because splitting the water molecule in oxygen and hydrogen requires a lot of energy. So this means that hydrogen plants need to be near the power plants. The power plants gives the energy, then the hydrogen plant generates from electrolysis this hydrogen. They put it inside bottles, and this bottle then can be used inside our vehicle as the fuel source that then the vehicle uses to move. Well, now the question is which energy source we should use to generate this hydrogen. We could use, for example, standard fossil fuel plants, but this would not provide any improvement respect burning directly the fossil fuel inside the vehicle, because when we generate the energy in this kind of plants, we are emitting carbon dioxide. So generating hydrogen that is a carbon-free fuel is not, so if we do it from this kind of sources, it is not interesting. The interesting thing would be to use greener energy sources, like for example hydropower, wind power and solar power, because when we generate energy with these sources, we are not emitting carbon dioxide. So this would be the good way to generate this hydrogen. The problem is that right now these three technologies cannot provide a lot of energy. So if we want to use right now hydrogen, we need to use some other sources that are able to give a lot of power. And one interesting way to generate it is through nuclear plants. Nuclear plants are able to generate a lot of energy without emitting carbon dioxide. Okay, let's now see which is the state of this technology, the current state of this technology. And to do this, we will compare the power that we can generate in form of hydrogen, and compare it with the power that we are using in our transport system. Here in this plot we have represented the power that we use in the different modes of transport. We have obtained this by dividing the amount of energy that we use in 1 year by this amount of time, and with this quotient we obtain the power that every day we are using in our transport system. And we can see that in light-duty vehicles, for example, we are using 2 million megawatts of power. For example, in trucks, we are using 500,000 of megawatts, and in buses, it's of the order of hundreds of thousands of megawatts. Well, these are very huge values compared with the current capacity, the world capacity of electrolysis in the world, that is only 300 megawatts. 300 megawatts compared with these hundreds of thousands of megawatt is like zero. So the current state of this technology cannot give enough power. So we need to improve a lot. So we need to generate a lot of hydrogen plants in order to be able to give to our transport system the capacity that it requires to move all our vehicles. In conclusion, we have seen that hydrogen is a very interesting molecule that can store energy and then use it in the transport system. That is ideal for heavy vehicles because it has a capacity to release a lot of energy. And that we must increase a lot the number of power plants in order to be able to give to our whole transport system enough energy.